In the year 2003, the world watched as NASA's rovers explored the surface of Mars. One of the rovers, Spirit, soon discovered a rock that seemed out of place among the rusty landscape. Its composition was unlike anything seen before. No one was sure where it came from or how it got there. But one scientist had an idea. Kenneth Edman, a professor of Earth and planetary sciences at Washington University in St. Louis, thought the rock might have originated from outer space. Maybe it was part of a meteorite that fell to Mars from another planet, or even another star system. The rock contained minerals and isotopes that suggested it had been through the ringer, had spent years hurtling through the depths of space. The catch was proving it. To find out where the rock really came from, Egerman needed to figure out its age. But that proved trickier than he expected. You see, radioactive dating only works up to a certain point. It requires measuring the ratio of parent atoms to daughter atoms in a sample. But in the case of this rock, the ratios were off. The number of daughter atoms was higher than expected. Edman and his team realized that the rock must have been formed long ago on another planet or in outer space. It was much older than the 4 billion years of Mars, and thus began the search for an extraterrestrial origin. Back then, science fiction was the primary source of conversation about life outside of Earth. Science articles talked about theories for how life might evolve on other planets, but no serious evidence had ever been found to confirm those ideas. However, this particular rock changed all that. With the help of an international team of researchers, Edman used mass spectrometry and electron microprobe analysis to examine the rock's chemical composition. He uncovered evidence of water and carbonate deposits, which suggested the rock had once been part of a watery environment, maybe a lake or an ocean. These discoveries were published in Nature magazine and sent shockwaves through the scientific community. It was the first time anyone had found evidence of a prebiotic chemical reaction in outer space. We now know that organic molecules such as amino acids and nucleobases, the building blocks of life, can form in space and reach Earth via meteorites. Those molecules can interact with each assimilable building blocks of life. This understanding has revolutionized the study of astrobiology. But it's not the whole picture. For decades, astronomers have pondered why and how organic molecules combine to form complex structures. But that question remains unanswered. There are many proposed explanations and theories. Many researchers believe that conditions on early Earth may have played a role. Perhaps a volcanic eruption that unleashed chemicals from the planet's interior. Others believe that deep sea vents played a role. But so far, no one really knows. That's why the discovery of a rock containing amino acids and carbonate deposits on Mars is so important. It suggests that the building blocks of life can assemble in space, but the process of assembling those blocks into complex structures may require environmental assistance. Maybe life needs a little help getting started. Maybe it doesn't happen on its own. Or maybe we are completely wrong about what life is. In 2017, NASA launched the Cassini spacecraft to study Saturn's moon Titan. Titan is the only moon in the solar system with a dense atmosphere, and the only place besides Earth where liquids flow freely on the surface. As Cassini approached Titan, it captured stunning images of the moon's surface. But one image in particular caught the attention of scientists. It showed a vast dune field that stretched as far as the eye could see. Dunes are formed by wind blowing over sand or loose rock, piling it up into wave-like formations. But the dunes on Titan were unlike any dunes we had seen before. They were bigger, taller, and more numerous. And the winds on Titan are much weaker than the winds on Earth. So how were these dunes formed? Scientists believe the answer lies in the makeup of Titan's surface. The moon is mostly made of ice, which can be blown around by the weak winds. But Titan's surface also contains a lot of rock, and that rock is made up of particles much larger than sand. So how did those bigger particles get airborne? Researchers believe the answer may lie in the interaction between Titan's atmosphere and its surface. The particles on Titan's surface are constantly bombarded by organic molecules from the atmosphere. Those molecules form a thin layer on the surface, making it slippery. That slipperiness allows the particles to move more easily when the wind blows, eventually forming dunes. But that process would take a very long time. Scientists think the dunes on Titan are millions of years old. That means the wind must have been blowing steadily for a very long time to move the particles into place. But the strangest part of the dunes is what's inside them. As Cassini flew through the dunes, it detected a variety of organic molecules, including ethane, propane, and butane. Those molecules are usually found deep underground on Earth, but they're abundant on Titan's surface. That's because Titan's atmosphere is rich in nitrogen, which reacts with methane in the upper atmosphere to form organic molecules. Those molecules rain down onto the surface and accumulate in the dunes. But what's really interesting is the ratio of different molecules. The ratio of ethane to propane to butane is the same as the ratio in Earth's crust. That suggests that Titan's surface is made of the same stuff as Earth's crust. It's just been compressed and hardened into a solid mass. That means the dunes on Titan aren't just piles of loose material. They're solid structures made of the same stuff as Earth's mountains and valleys. They're a window into the interior of a world that's very different from our own. But it also suggests that Titan and Earth may be more alike than we thought. The universe is vast and mysterious. We have only just begun to explore it, and yet we have already discovered so much. The dinosaurs lived in a world full of volcanoes, meteorites, and comets. Life on Earth has always been shaped by the forces of nature. But today, we face a new challenge. Our own species. Is humanity smart enough to save itself? Is the fate of our world in our hands, or will we destroy ourselves before we understand the universe? How much longer will we live in ignorance? These questions have been keeping me up at night. But they don't have to keep you up at night. You can learn to trust in the future of humanity. You can learn to trust in the power of knowledge. Now check out this video right here. It's just the kind of thing that makes our channel special, and I know you'll love it. This is an extraordinary scenario, but it has already reached the halls of politics. Congresswoman Ana Paula Luna has gone on record urging NASA to track Atlas aggressively. She said plainly, "If there is even a chance this is technological, it is our obligation to prepare." For a sitting lawmaker to use those words is almost unthinkable. Yet it shows how much unease is gathering around this visitor from the stars, and time is running short. On October 30th, 2025, just weeks after its Mars flyby, Atlas will swing past the Sun at its closest approach. Days later, it will be visible from both Mars and Earth, a comet blazing across the skies of two planets at once. If natural, it will be the most spectacular interstellar display in history, a chance to study an alien comet up close. But if unnatural, if Atlas captures angles, shapes, or maneuvers that defy physics, then history will remember it as something far more profound. The first clear evidence of non-human technology crossing into our solar system. Even now, every week brings new images, and every image deepens the mystery. The tail grows longer, sharper, more luminous, glowing defiantly against the stars. The nucleus remains stable, locked in place as though engineered. The orbit traces its line closer and closer to Mars, so precise that it unsettles even veteran astronomers. Each detail erodes the possibility of coincidence. We are left with a question that no one truly wants to answer. Are we witnessing ice melting in the void, or are we staring at the disguised silhouette of a machine? Is Atlas a natural comet wandering in from the interstellar dark, or is it a messenger purposeful approaching Mars with intent? In just a matter of weeks, we may know. The Mars Reconnaissance Orbiter will take its images. The James Webb Space Telescope will add its data. And for the first time, humanity may have to confront the possibility that we are not alone and that another intelligence has entered our solar system, not with a signal, but with a craft. Until then, the comet blazes forward, its luminous tail unfurling like a banner against the night, daring us to watch, daring us to wonder. And all we can do is wait. Our telescopes ready, our eyes on the sky, and our imagination racing faster than the comet itself. So now I want to hear from you. What do you think Atlas really is? Are we watching an extraordinary comet unlike any ever seen before? Or could this truly be the first undeniable sign of technology not made by human hands? Drop your thoughts below because the debate is only just beginning. And if you want to follow every twist of this story, from the nickel mystery to the Mars flyby to whatever comes after, make sure you subscribe and hit the bell. Because in October, when Atlas brushes past Mars, we will finally face the truth, whether it is natural or whether it is something that changes our understanding of the universe. It is tempting to dismiss it as a distraction, a mere interloper passing through our cosmic neighborhood. But here's the unsettling truth. Atlas is not merely visiting, it is on a collision course with Mars. This is not a random occurrence. Every astronomical body in the solar system follows a predictable path dictated by the laws of gravity and their own inertia. Atlas is no exception. Its trajectory is a carefully calibrated course, one that has brought it within tantalizing distance of our red planet. Why Mars? This is where the enigma deepens. The planet Mars has fascinated humanity for millennia. It is the most explored planet in our solar system and the most likely candidate for human colonization. But why would an interstellar visitor, comet or craft, choose this particular world as its destination? Some speculate that Mars holds the key to the survival of our species. Others argue that its resources or its past could hold vital clues to the existence of extraterrestrial life. Could Atlas be on a mission to study, to harvest, or perhaps to warn? These questions are not science fiction. They are grounded in the very real possibility that Atlas could be an exploration vessel, a probe sent out from a distant world to gather information about our solar system and its inhabitants. Imagine for a moment the implications of such a discovery. An interstellar probe sent not to invade, but to observe, to understand. The potential for knowledge is staggering. Think of the insights it could offer into the universe, into the nature of space travel, into the possibility of life elsewhere. But such discoveries rarely come without challenges. The revelation of an alien probe on a collision course with Mars would undoubtedly send shockwaves around the world. It would challenge our understanding of the universe and force us to confront the reality of our place within it. Yet it is precisely this challenge that makes the discovery of Atlas so vital. It is a wake-up call, a harbinger of what is to come. Whether Atlas is a harbinger of invasion or a herald of exploration, it is up to us to decide. But to make that decision, we must first understand the full implications of what we are about to encounter. As the comet hurtles toward its rendezvous with Mars, we must prepare not just for the scientific marvel, but for the profound philosophical and ethical questions it will raise. The coming months will be a crucible for humanity. They will test our curiosity, our courage, and our capacity for understanding. They will also test our readiness to embrace the unknown and to confront the profound mysteries of the cosmos. Are we ready for what Atlas brings? Only time will tell. Okay, now it's time to hear from you. What do you think Atlas really is? And what should humanity do as it approaches Mars? Your thoughts below because the debate is only just beginning. And if you want to follow every twist of this story, from the nickel mystery to the Mars flyby to whatever comes after, make sure you subscribe and hit the bell. Because in October, when Atlas brushes past Mars, we will finally face the truth, whether it is natural or whether it is something that changes our understanding of the universe.